Okay, so welcome to lesson 4 on the first part of the practical problem solving and programming. So today what we're going to look at first is pseudocode. So pseudocode is a simple method of showing an algorithm using English-like words and mathematical operators that are set out to look like a program. So here we've got a set of pseudocode here. Okay, so we're going to have a look at what this pseudocode does. Okay, so we've got the repeat command. Now the repeat command is like a loop, but it carries on until a certain condition is met. Okay, in this case, when the time equals to alarm time. So this pseudocode waits 10 seconds and gets the time, and then once the time matches the alarm time that has been set, then it will sound the alarm. Otherwise, it will keep repeating and will wait every 10 seconds until the time matches the alarm time, and then the sound and the alarm will sound. Okay, so we're going to watch a little video on what pseudocode is. Enjoy.
Welcome to 5 Minutes to Code, Programming Basics with your host Matthew C. Applegate. In this series, we are going to look at the fundamentals of computer programming. So whether you are hoping to program in Python, to code in C#, or to develop in Java, these short guides should help you get to grips with the basics to get started. You won't need to download or install any software, so just sit back and enjoy. In this series, we are going to be looking at sequence, selection, and iteration, as well as pseudocode and flowcharts. Today, we're going to look at pseudocode. So let's look at this in more detail. Okay, here is an example program written in pseudocode. It both does and doesn't look like a computer program. The syntax is similar to most high-level computer languages, but at the same time, doesn't have the exact syntax. Pseudocode is often referred to as a syntactical representation of a program. Why do people use pseudocode? Well, it has two very useful uses. Firstly, it can be used to help non-programmers understand what is happening in a program. The second use for pseudocode is for when programmers are trying to debug and solve a logic error in a computer program. As it is closer to spoken language, it often helps programmers find where the program is going wrong. Let's look at our first program in pseudocode. Okay, the first line is pretty straightforward. It is a comment. A comment is ignored by the program and is used for us humans to read. It helps us remember what something does, and if you are part of a team of programmers, it can help explain what it does to another programmer. The second line, the a variable, is assigned the value of 10. This arrow means assignment. It is similar to a single equal symbol. In this case, a equals 10. The same thing is happening with b on the next line. However, b is being assigned 20. Line 4 totals a plus b together and assigns it to c, so c is now equal to 30. On line 5, d is being assigned c divided by 2. This effectively halves 30 to 15, so d is now being assigned 15. And finally, print d. This is an output command. It takes something from the computer program and shares it with the real world. It outputs the value of d to the screen, which in this case is 15. So there you go. You can have comments, variables, and outputs in pseudocode. But that is just the beginning. In fact, most things can be achieved in pseudocode. Let's look at another short program. This simple program takes 4 user inputs and adds it to the total at the end. The first line is a for loop, 0 to 4. The variable count is initially set to 0, and every time around the loop it adds 1 to it until it gets to 4, and then it breaks out of the loop. The first thing it does in the loop is to ask the user to type in an exam score. The next line, number equals user input, assigns the number that is input to the variable score. Following this, it adds it to the total variable by taking the existing total and adding the new score to it. It then calls next count, which effectively adds 1 to the value of count and goes around the loop again. Once it has done this 4 times, it creates the average by taking the total and dividing it by 4 and assigning it to the variable average. Finally, it prints the words the class average and the average as an output. So there you go. We have now added for loops and inputs to the mix. This is just a short guide to pseudocode. Now that you have the basics, don't hesitate to dig deeper into it and flowcharts as well, as they are very useful tools to use. You can check out other programming basic videos here, and they will help you get started.
Okay, so from that video, we've learned that pseudocode is a notation resembling a simplified programming language. And like flowcharts, they are used to communicate the algorithm showing how a system or subsystem works. So in the previous lessons, we've looked at flowcharts. So now we're going to look at more ways to actually solve a given problem, okay, using pseudocode. So the outcomes or the objectives of today's lesson is to know how pseudocode works, understand the purpose of library routines, modules, and suggest and apply suitable test data. Okay, so we're going to have a look at library routines. So a library routine is basically a set of programming instructions for a specific task available to us. The idea is that this library routine is normally built in. The idea of this inbuilt library is that someone has already created this, they've debugged it, they've tested it multiple times to make sure that it works, and then they make it available to everyone, okay, within a given language. It's the idea where you have certain different programming or little bits of code. You don't want to keep rewriting yourself. You just use it. If it does a particular job, you would just essentially cut and paste that particular code into your program. What we're going to have a look at next, we're going to have a look at an example library routine in a Python program. Okay, so here is the library routine to generate a random variable, and there's various different functions in here that you can actually extract. But for you to use this library, the random library, you have to first import it into your chosen program. So this library routine actually does quite a lot of stuff. So if I just scroll down, we've got where you would get a random number within a range. So you have your start and your end range. We've got a function here where it gives you a random number between two given integers. You have, let's have a look, you have where it shuffles, random shuffle. If you're importing that into your program. There's quite a lot of other programs here, or sub-programs in here that you can actually extract. Now how it works is, if I scroll across and show you this Python program. So this Python program is a rock, paper, scissors game. And the idea is that this computer will play, or this program will play 3 rounds of a rock, paper, scissors game. And the idea is the best of 3 wins. Okay, so what normally happens, I mean, it's not fully finished, it's something that I'm developing. So the idea is I need to import random first. So I've got my library routine, my random library routine. I've got a sub function here, so this is my subsystem. So this is where the user selects a choice, whether it be 1 for paper, 2 for scissors, 3 for rock. Then we've got the computer selection subsystem. And the computer actually selects a number between 1 and 3, but it's generated random. Okay, so I've used the randint subfunction within the random library, and I've asked the computer to select a random number between 1, 2, and 3. Okay, so it picks a random number between 1 and 3, and it saves it into that variable number. Okay, once I've done that, then it goes to the main contest. Okay, so it will obviously decide whether the user or the computer will win, etc. Okay, and yeah, that's how I've used the random library in this program. Okay, next we're going to have a look at validation. So validation, what is it and why do we need it? Well, validation is basically the computer's automatic check to ensure that data that is entered is sensible and reasonable. Just remember, it does not check the accuracy of the data, although the computer can be programmed to accept certain numbers, let's say between like numbers 11 and 16. Therefore, that would probably fall in a range, which case it's called a range check, which is what we're going to be looking at as well. So here are a list of common systems, and in lesson what we did, we looked at what you thought the validation rules might be of these. So I'll let you pause the video here and think about some of the possible validation rules that might exist in these 5 systems. And then what I'll do on the next slide, I'll talk about the different validation types and see if you've got the right idea. Just pause it there. Okay, so here are the validation types. So you've got check digit, and basically this works where the last 1 or 2 digits in a code that are used to check to see if that the other digits are actually correct. We did this in lesson where we looked at barcodes, and we ran the check digit on there. There was 2 versions. There was the modulo 1.3 and the modulus 11 system, which we'll go on again in a future lesson. Then we've got a format check, which checks the data is in the right format. For example, date of birth, that the format is right, day, month, year. Or we've got an example there, national insurance number, where it starts off with 2 letters, then 2 numbers. You've got the length check, checks the data isn't too short or too long. You've got a lookup table where it only accepts acceptable values within a certain table that you've set up. We've got a presence check where you cannot leave a field blank. We've got a range check where whatever numbers you put in, they have to fall within a given range. And then you've got the spell check, which looks up words in a dictionary. Okay, so if you navigate yourselves to the following site, use the username and password there, and have a go at some of these quizzes based around validating data, and in the next lesson we'll look at it a bit more.